So yes, I'm not happy with the two 90-degree bends in the pipe. So one day you should consider changing those. Now, for 1 or 2 days, I've been saying to you, I can smell rubber. Okay? So nose and ears are very important in a plant. Sometimes you can hear, with your ears, you can hear a belt screaming. That is a sign that the pump is about to bog. In a big plant, you would have amperage meters in your control room, and the amps would start to go up on the motor, and that will tell you you're about to sand up. But you can use your ears for that. You can use your nose. So even after a pump has sanded up, and we think, oh, maybe the rubber smell is because it's sanded up. If you can smell rubber in a plant, we should investigate. So today we took the cover off, and we, in a belt, just so you all know, I know you're not mechanical people, but on a V belt, you should be able to move the V belt 12 mm. 12 mm. When we took the cover off, we were getting 50 to 70 mm. So it was very loose. So that means that any little bit of pressure, the belts are going to slip, the slurry velocity slows down, comes back down the pipe, actually turns the impeller backwards, and boom, we're bogged. Okay, so today we found that it's loose. I think your problem is solved. Okay, so there was some learning, mechanical learning in that. I know that you saw it as a problem on the day, but in hindsight, we actually learned something from that. And that's very important. More so than you, it's more important for the technicians down there that are running the plant to understand that.
So another thing that we learned,
Yes.
It's gone into hyperspace.
জুম আউট করুন হাত আগে হাতটা দিয়ে হাতে ক্লিক করুন হ্যাঁ এখন no it's not set. You're not set. That's why physical body is always better.
Yep. Agreed.
There is no history or something.
okay, the another thing that we have learned that IRMS
Fractionation.
fractionation.
So you have been given a flow chart.
Yeah.
That is a world standard.
Day two.
IRMS fractionation.
So not only did we learn how to do that fractionation, but we also talked about how important it is if you were to get a new sample in, a new feed sample. The first thing you would do is a bromoform to understand the HM content. You would do a size analysis to work out the PSD of that sample, and you would fractionate it on the IRM. Because the IRM can tell us a few things like how much non-mag is in there, but it can tell us whether we have highly magnetic ilmenite in mag 1, or does all the ilmenite go to mag 2 and 3, which means it's highly altered.
Okay. Last session চলতেছে question answer is the analytical level.
IRMS fractionation. Okay.
Yep.
Yes.
Do some.
And I guess doing that, we also learned about taking a representative sample from a wet sample, and that was a cone and quarter.
Yeah, 1 and quarter. More from separation.
Can you give Dr. Jamal?
We also conducted raw form separation to watch how many
To work out our heavy mineral content.
heavy mineral contents are there.
And from that gave us a guide to go back to the plant and make adjustments. So that goes to show us how important it is to take a sample, get a bromoform separation done, and that tells us whether we need to go back and make more adjustments. Which we did. And we've gone from 69% HM up to 90. last sample was 90. So we're between 73 and 90. So we're getting right up there now. It's very good.
That is 73.8. So yesterday 69.something. We are around 4% increased, and one sample we got 90%, and that we have adjusted purposefully. We have adjusted the splitters accordingly so that we understand whether the grade can be increased or not. So the grade can be increased. Yes. That is by adjusting the splitters, the grade can be increased. But to get the more recovery, we have to make splitters.
How percent is better for liquid?
Like what is the suitable optimization?
That's why, as he told, 90% is very, very good. But in the plant also, we are expecting 90%.
So
We got
above 80,
90%.
above 80 is good.
Above 80 is good.
Yep. Because when we come to our dry plant, at some stage we're going to have to go back to a wet circuit, which will be the shaking table. So yes, we also spoke about the inclusion of UCC. We spoke about how we would operate that UCC, and I suggested that you read the manual, you start to understand that unit, and we start to do some testing, because in the last few days we have learned that we have very fine silica.
Yes.
Very fine silica will always tend to go to the concentrate of the spiral. So the question is, do we put it in before the WIMS or after the WIMS? So that will be test work that's required. So the next stage for you is to start to use the UCC so that you can understand it better. Currently it is sitting here in the laboratory. I personally feel it would be better if it was down at the plant. This evening I will draw you a hand drawing for a hopper that you can have fabricated, and I will design it so that it has big hooks on the back, and you can hang that on the first floor of your spiral rig. You can hang it on the handrail. You can have your UCC down on the floor, and we will use an orifice plate to give us our tonnage. So with that little UCC, you're probably looking at about 30 kilograms per hour. So to make an orifice plate, you basically have a washer. Okay, different size washers, and you just keep putting the washer in until you get the right size, and you just measure, you time it and measure until you get 30 kilograms an hour, and that is our orifice plate. So that will sit in the hopper. Pour your sand in and start running. So whilst that's running, you can have 30 or 40 kilograms in that hopper. Your UCC is down the bottom. You have your water running. You introduce the feed. You let it run for about 5 or 10 minutes until it reaches what we call equilibrium. And then you take a sample of overflow and underflow. You put that aside. You then make an adjustment on the upcurrent water. Okay, so start low and keep increasing. Take another sample. Increase some more. You increase it until you start to see the black heavy mineral coming to the overflow. Once you see black heavy mineral going to the overflow, that's when you stop. Okay? And then we go and analyse those samples. You can do a bromoform and you can do a PSD. Now from that information, we now know how to operate the UCC. We know the upcurrent water flow. So that when you have, if you go down the track and you want to purchase one of these units, you can tell the supplier that this is the PSD of our sand. This is the test work we performed in this size unit. And this is the upcurrent water we used. And from that, they will design the right size unit. Your unit will be small, probably 1 tonne an hour. I sort of envisage a 300 by 300 millimetre unit. That's so big. And that can run in line. So once we set it up, that will run with your plant. So there'll be no more test work required. It will just run.
As an extension of this plant.
As an extension of that plant. So what we found this week is that the fine silica is a bit of a problem for us. And if we keep that silica in there, it will follow the non-conductors. So At the end of the day, as we get down to the non-conductors, the silica will compound. So we might have 4% in our heavy mineral concentrate. We then take away the conductors and the mags. We might find our silica is up around 8 or 9%. That is too high. So the UCC will remove that. Okay. That is common practice for any plant that has fine silica. And as the world moves away from beach mining because of environmental concerns and population growth, as the mining moves inland, we're finding that the sand, raw sand, is becoming finer and finer, and the upcurrent classifier now has become a standard feature.
So your current classifier is nothing but your existing cross flow.
Yes, cross flow.
Cross-flow separator.
Yes.
And so far, remember, today we had
correct sample.
lecture.
So we learned a lot about
The
The-
basic
the-
principles.
Basic
the basic principles of spirals.
Spirals.
Basics of spirals. Yes. Right on this.
So once again, we refer to the importance of understanding each piece of equipment. So once you understand the equipment and you understand the minerals that you're processing, it's very easy to make decisions in the plant on the run.
Yeah, that is more important. Understanding of the minerals.
Shivam, ওই যে UCC কাট অফ গ্রেড
এটা ডে 2 তে আমরা ইউসিসি সম্পর্কে জেনেছিলাম আর কি।
আচ্ছা
আপকারেন্ট ক্লাসিফায়ার
ক্লাসিফায়ার এটি ওই ক্লোজ করেছে।
মানে আমাদের ফ্লোটেশন ল্যাবে একটা ইয়ে আছে, মানে আলাদা যন্ত্র আছে যেটা দিয়ে
ক্রস সেপারেশন।
হ্যাঁ, ক্রস সেপারেটর। ওইটা কি হ্যাঁ, ওইটাই হচ্ছে ইউসিসি।
That is same. Some few people call hydro classifier. Few people call cross flow classifier, cross flow separator.
টুডে
classifier.
ইমাম ভাই সেপারেশন কাট পয়েন্ট ছিল আজকে একটা।
So in the spirals, so we learned about the principles of the spiral itself, but we also learned something about your plant. So we have rougher spirals and we have scavenger spirals.
Yes.
And we have a cleaner section.
Yeah.
So we've learned that the rougher and scavenger spirals are for recovery, yield. That's where we want to recover all the heavy mineral we can and just reject clean tail. So to monitor that, we do bromoforms on the tail. And if we're around that 3%, we know we are okay. If it goes up, we know we need to take more concentrate from those roughers to maintain our recovery. The cleaners are for maintaining grade.
So we also have separation cut point.
Yep.
3.6
The diverter, the
Yes.
scale.
So we learned today, we did a lot of work around using the finger diverters.
Finger diverter.
Yep.
Repulper.
And the finger diverters were to remove. What were we trying to remove?
Fine silica.
Fine silica sitting on the surface of the HMC. Correct. So with the finger diverters, we made a small wave just around the outside of our splitter, so that we're removing that fine silica.
Yes.
And by doing that, we saw a major increase in our grade.
Okay. Another thing was leaching agent.
What is leaching agent?
Leaching agent means the surface.
No, that is not.
Release.
Yeah.
Releasing
agent. Sorry.
Okay, so
That is how you have to maintain the spiral.
so remember the releasing agent.
Releasing.
Release agent is only a temporary thing. It's something that comes from manufacturing of the
Yeah.
spirals.
So
And in a plant situation, that releasing agent would be removed within 1 or 2 days because there's such high tonnage.
Yeah.
In your situation, you're running a much smaller tonnage, so we have to use a bit of hand power. Now, we did that on the rougher and the scavengers, and we noticed an instant improvement. We still have a little more to do on the rougher and cleaners because they are taking a much less load. So as I said, if you are still having trouble just by using the brush, that should work. If you're still having trouble, you could use a little bit of acetone, not while the plant's running, but a little bit of acetone and a brush, and that should remove that release agent. Once it's gone forever.
But there will be possibility to have corrosion using brush.
No.
And let's
No.
say
Erosion.
Plus it will not happen.
Erosion.
Erosion.
No, the surface of the spiral is
corrosion,
coated.
erosion, corrosion নাকি?
Erosion.
Erosion.
There is
Yeah,
erosion.
the
Corrosion
surface
of
of the
metal.
spiral has a polyurethane coating that is impregnated with zirconium. So the surface of that spiral will certainly outlive you. It'll be there for a long time. So no, don't worry about brushing it. And the brushing is only for the first few days. Once it's gone, it's gone. You won't have to bother again. But in saying that, it is important to maintain your spirals. So over time, because you're using fresh water has natural algae in it. So we run the plant, we shut down and we just walk away and we go home each day. So over some time you may find that algae starts to grow on the surface. Once again, just brush it off.
Yes.
In a plant, we ask the operators once a week to shut down and maintain the spirals. Just they either blast it with a high pressure blaster, because there's thousands of them, but in your situation you can just quickly brush it as soon as you see some algae. It'll be months before you have to do it.
Okay. Rubber smelling.
The rubber smelling was to do with pump 4,
Harmful.
so there was a good learning for everyone in that one. Not only do I have a big nose, but as I said to you, if you smell rubber,
Yes.
there's something not right. And I know it's a lot of work. You got to shut down, but it's worth it because, gentlemen, I think it was much easier to stop the plant, take the guard off, adjust the belt, than it was to unblock that pipe 3 times.
Okay.
Okay.
Then we have
So I think we have fixed pump 4 problem solved. We did a lot of work on the microscope. We discussed the different minerals.
Yes.
Alan, as I promised, if I can find this document a paper that I wrote some time ago, I will share with you. It's about physical grain counting and mineral identification for beach sands. We talked a lot about that today, about kyanite, sillimanite, zircon,
Yes.
how we can identify those minerals. So you need to purchase some methylene, some benzyl benzoate. That is your refractive index.
Yes.
So methylene iodine is a heavy liquid that will help you remove silica. It's analytical. It's not something you use in the plant.
Yeah.
It's
Benzoate
analytical
is using especially for polarizing microscope.
Yes.
Okay.
So with the benzoate, you can use your polarizing.
How much benzoate?
So you know the glass eyedroppers that the doctor uses to put drops in your eyes.
Yes.
You use one of those
এই যে চোখে যে
and probably 2 drops.
2 drops.
2 drops on the slide. On the
Is it
microscope.
medicine?
No, it's poison.
Used as
I don't think so.
I think the chemical soaps, they only I think can sell this.
Okay, well I know that at times when I use it, you will get a bit on your fingers because you're handling the slide. And I know in my time that I've accidentally scratched my eye, gone to wipe my eye, and the benzoate, it makes you jump around like a donkey because it burns. So it's a refractive index, I think, of 1.6. That will help you in your identification because it takes some time to set up the SEM. The SEM works on a chemistry factor, I understand that.
Yes.
But when you're looking under a microscope, see the SEM gives you an assay. It tells you that you have sillimanite, you have zircon. That's all it tells us. So what I need to know is the physical properties of those minerals. Is the sillimanite coarse? Is the sillimanite fine? And SEM can't do that. But you, looking down the microscope, can tell the plant operators, hey, we have very fine sillimanite here.
Yeah.
Okay, let's use the UCC.
Looking at this color, that is rainbow color.
With the benzoate. So you'll see the 3rd order colours. You'll see the cleavage you'll see the elongated cleavage on sillimanite, the cleavage going across the grain on kyanite. Zircon has no cleavage and no colour. Now, this is going to confuse the matter. If you have zircon that's below 50 micron, it will show third order colours. So you'll then have to look for the high relief. So with benzyl benzoate, when you look at zircon with the transmitted light, you'll see a very high relief around the zircon.
High relief.
High relief.
Yeah.
So the physical operation of a microscope is very helpful in mineral sand processing. The methylene iodine is an analytical tool that can help you analyse. If you are struggling to identify sillimanite, you can use methylene iodine. It's the same as bromoform. You put it in a separation flask. You do a separation. The sillimanite will float. The heavies will sink. You weigh the two fractions. That percentage is your assay. That is your percent of sillimanite in this sample. So it's a very handy tool. Now, I understand if you're using the same sands all the time, you will become familiar with your own deposit. But as you're a research centre, you could be working on deposits from all around the world from your clients. Okay, and they're not going to know how much sillimanite is in there, but you can find this out by using these physical properties. We did some discussions around the high tension,
rare earth roll separator.
the rare earth roll separator. So we learnt a lot today with the rare earth roll separator. So flotation is one way of removing monazite from zircon. Certainly, it's very selective. A rare earth roll can remove monazite from zircon, and it's environmentally friendly. Okay, so there's an option for you that you learned there today. The high tension roll, we spoke about, it's a primary separation in the dry plant. We spoke about roll speeds, we spoke about kVA settings and temperature. Remember, temperature is critical in a plant. Okay? If we have low temperature, the atmospheric conditions will affect the mineral surface and we'll get a different separation. If the temperature goes too high, so I've mentioned to you 100 degrees on the primary separator, if that temperature was rise to 140, what happens is all the non-conductors stick to the roll. Everything sticks to the roll and you don't get a separation. Now you're probably looking at me going, well, why would we take it to 140 degrees? Well, I can tell you in plants around the world it happens, particularly on back shifts where people are sleeping or not bothered about their plant. The dryer gets hot, the oil goes up, next thing we're running at 140 degrees and the plant grade goes off all night. Okay. When you do your flow sheet design, so when you're designing your flow sheet for dry mill, you need to insert all the conditions you used, roll speed, kVA, temperature,
ampere,
so that when the engineers design that plant, they have all this information. We then learnt that the high tension roll is a primary separator, and that if we have coarse non-conductors, the centrifugal forces will throw those non-conductors into the conductor stream. And if we run it over the HDR again, the same problem will continue to happen. So that's where the plate machine is used. The plate machine is used to take coarse non-conductors away from fine conductors. So tonnages, can you remember tonnages on the high tension roll and plate machine?
You say 30 to 40 kg per hour, something like that?
Tons per hour. So I won't put you on the spot, but you can read the manuals and I will send you the documentation that I said. But in a plant situation, I would suggest 2 tonne per hour maximum on a roll and 1 tonne per hour maximum on the plate machine.
Documents.
Now, with the plate machine,
Do you have the?
আন্ডো করা যায়
This is the minimum size.
30%.
But you write in minimal position.
okay, so the plate separator, we know what it's used for. Temperature is critical. Okay, temperature is critical, maximum 80 degrees. and low tonnage, 1 tonne per hour maximum. So gentlemen, remember that when we talk about tonnage on these machines, we're talking about the full plant machine. So you have to scale that down to your laboratory
This is,
machine.
1 ton per hour on the plant machine.
Plant machine.
Plant machine.
Not for the laboratory.
Okay.
So when you read your manual, when you read your manuals, you will see that the high tension roll separator is 1.8 meters in length, 1800 millimeters. So you measure the feed width on your HDR here, which I think is 100 millimeters. So the factor is 18. Okay.
Set করে দেবে এটা সমস্যা নেই
So ultimately, I'd like to know from you your overall recommendation or suggestion.
Another thing missing, the dry limbs. It suggests the dry limbs for magnet separation.
Yes,
Okay.
that also you can.
I suggested the dry limbs based on your request. So what we found when we came into the laboratory was we looked at the RED and we could very quickly tell that you've been using magnetite on the RED. Now how could we tell that? Okay, magnetite is highly susceptible. 900 Gauss is all that is required. The drum magnet is how much Gauss?
Almost 900,000.
7,000.
700.
7,000.
7,000.
And magnetite likes 900 Gauss. So the magnetite will never remove itself from the roll. So every time that roll spins, you are wearing the roll out. The surface of the roll is being ground away by the magnetite. Magnetite is very angular and it will cut through your roll. So the RED is not to be used to remove magnetite. So I showed you that we can use the IRM. 0.3 amps, 10 millimeter air gap. That is all on the flow chart that I gave you. Now your concern was that it's very slow. So I guess first I want to highlight is that we are not a production plant here, we are a laboratory. We can run that IRM at 150 kilograms per hour. That's not bad for a laboratory. If you have a bulk sample, if somebody gives you 10 tons, I would run it over the wet limbs. Okay? But if you have a bulk sample and you want to be able to increase the throughput, the thing to use is called a dry limb separator. Now many companies make them and you can buy them from China, but I'm going to say this clearly to you now. This is a research centre and it's a world standard. Please do not go and put Chinese equipment into your laboratory because it just does not perform as well as the others. So there is a company in America called Aries that make them. There are other companies in the world too that make them. But Aries make a dry limbs. It's a 400 millimeter diameter magnet and it's 300 millimeters wide. That will probably treat about 700 or 800 kilograms per hour, maybe even a ton. But it's a dry separation. At that tonnage, it will throw out a lot of dust. So it's probably something that you want to do outside, maybe in a dry part of your plant down there. I wouldn't have it in here because there'll be a lot of dust. So we've learned that the IRM can be used to remove magnetite.
I think they should follow that process because whenever they are getting WIMS mag, in that if any magnetite is removed, then it's better they try with the IRMS, first remove the magnetite and then they can feed to the
Layer drum.
So, look, just so you're aware, I used to manage a very large laboratory in Australia, and we were well known all around the world for designing flow sheets, both wet and dry. So we had a big pilot plant, wet pilot plant, full scale, just like you have. But in our dry plant, we only had the same equipment that you have here. And for 30 years, we have produced thousands of flow sheets for around the world just by using the IRM. All we did was we made a large hopper that sat on top of the machine so that you can fill it up and then you can just work with the products. So these things are feasible. It's much cheaper to build a hopper than it is to go and spend $30,000 US on a limbs machine.
Yeah. In our market, in our country, we available form benzene benzoate as a medicine. Can we use this?
Really?
Yeah, you can see.
As an eyedropper.
For scabies, okay.
No, I know it is eyedropper. It is used for skin diseases.
Skin disease.
Well, there you go. That is what you want.
Can you try it?
এটা পার্সেন্টেজ কত? এটার পার্সেন্টেজটা?
এটা ইমালশন আকারে পাওয়া যায়। পার্সেন্টেজটা যে কত দেখি।
এটা তো ইমালশন হিসেবে পাইলে এটা ফুল
The
percentage একটা fact.
Okay, so
হ্যাঁ
recommendation, a Gauss meter is very handy. You do, if you read the manuals, and as today I told you the Gauss on your machines, so it's not really required because you don't go and manufacture equipment. But a Gauss meter is used in many laboratories,
Okay.
but they're not a cheap item. It's about $2,000. Benzoate, I would highly recommend. I would highly recommend methylene iodine.
1.25 gram per 5 ml.
The shaking table you have,
You already have this.
now your comments to me was that it doesn't work. So I went and had a look at that shaking table and instantly I could see the problem. Shaking tables must be bolted to the floor.
Yeah.
They must be solid
Yeah.
because they have an action, they have a bump stop action. Okay? And with that bump stop action, what we're doing is as we go forward, we are accelerating the minerals. As we stop, we're decreasing the minerals. And with the difference in SG, we start to separate. If the machine is not bolted to the floor, that action has been lost and it won't work. Now, I know that Holman have supplied that table with rubber feet. It's just not going to work. Now, you can go and talk to Holman. I know Chris Bailey well, and I have had many arguments over the years with Chris Bailey, trying to tell him that with my experience in plants that some of his machines were not right, and he just argues it and he won't listen. But I can, hand on my heart, tell you that if you bolt that table to the floor, it will work. But when you bolt it, the frame that it's sitting on must be level.
They
Okay.
have the option. They can just.
And then you can adjust the table deck for the slope. There are no standard, remember I said there are no standard parameters for the shaking table. Every sample will act differently depending on the SG of the particles and in particular the particle size. Fine mineral will act very differently to coarse mineral. So coarse mineral, you will have a much less slope. Fine mineral, you'll have a much steeper slope. So there are no standard parameters. As far as water is concerned, a basic recommendation would be, as you put the dry sand in the feed box, I would say 3-to-1. Dilution water, 3 parts dilution water to 1 part feed. And I think they take about 25 litres per minute for wash water. But once again, the shaking table is something you do visually. You can tell whether you need to change the angle. You can tell visually whether you need to add more wash water.
And pump for pipe for tailings. This is
Okay, so for a few days we kept having trouble.
Yeah.
And we were blaming the 2 elbows.
2 elbows.
I admit that we were blaming the 2 elbows. But as I said, I kept saying to you, I can smell rubber. There's something wrong with the pump. Today we pulled the pump apart, we found that the belts were loose.
Okay. Yes.
I believe that when you run that plant tomorrow,
Tomorrow.
the problem is gone.
Okay.
Okay.
And today, the pump was also not jamming, so I don't think
It won't jam now.
Now the belt is also tightened, so I don't think any other problem will be there.
So just remember also right up there
Today
that
we measure another step. Sometimes we are opening the valve of some tailing sump, so that the tailing pipe would not be jammed.
It's also effective.
I don't think that's a problem anymore.
We have to
Which one? I didn't get you.
Pump 4.
Actually, in pump 4, the sump is deposited. We just clean them sometimes a few minutes after. So it gets cleaned. So that's why we think that today the pump didn't jam.
But all that sums are same design.
It's okay. Whatever you were doing before this afternoon is irrelevant. This afternoon, we finally took the cover off the belts we proved that the belts were incredibly loose.
Yeah.
Incredibly loose. We were lucky that it was pumping at all. Okay? So now we have adjusted the belts.
Yeah.
The problem is gone. But there's a learning from this. If you smell rubber again,
Check that out.
shut the plant down, adjust the belts. I would suggest to you that if you have a maintenance team or a mechanical person, once a month,
Once a month.
you should check all the belts.
Once a month.
Now, with the pulley belts, there should be movement of 12 mm, not 75 that we had today. Those belts were looser than my underpants. Okay? And to think that we struggled for 3 days because the belts were loose.
Which is 12 millimeter, which is?
So when you take the cover off, you can see the belt.
Belt.
You take your hand and you squeeze the belts. It should only move 12 mm, whereas today it was going like this.
12 mm. 12 millimeter minimum.
Minimum.
That means the belt.
Maximum.
The belt were so loose.
So
It
loose.
should be tight.
Tension.
So that's only
Tension.
12 mm only it should go.
Okay.
Yes, it should be tight.
হারিমে বুঝছেন তো আমি যদি
I think it's clear.
মানে
So those belts on pump 4, they are very worn now.
Yeah, on.
Okay, so I would suggest that next time that the mechanical person has a look at the belts,
They can replace.
it's probably in the manual, but write down what the belt size is, and I would suggest that you have 5 or 6 belts in stock.
Yeah,
Stock.
always. That's more important. Always keep stock of the belts. Because those big belts you may not get immediately in the market.
Yeah.
It's better you can keep some stock.
but rubbery
That's
belts
it. Frequently, sometimes the pump is running and the belt will come out.
but rubbery belts may decay,
This type of belts are available in our local market.
but it is available in our local market, so if it happens then we go to market and then buy. Instantly.
I would still suggest you, even if you have 2 belts here,
Yeah.
You can
So-
keep some belts so that
Must have
that
some
is-
stock.
I'll just give you a scenario so you understand why I'm saying this. Let's say you have some clients come all the way from Norway, taking them 3 days to fly here, and they've only got 2 days on site, and you've got to do test work for them, and the belt breaks. Do we have time to go out to the market, look for a belt? But if you've got one in the stock, just go and have a cup of tea, sir, we'll put a new belt on. Away we go. That's the beauty of having some stock.
Yeah.
always critical items you should keep the stock. Critical items, not like high cost items, but which are easily replaceable. These are replaceable belts. So we know that after few runs the belt will go.
Holder select করতে হবে
একটা slip.
So, gentlemen, I think you've learned a lot. I think you've learned a lot this week, and I have to say that I've probably flooded your minds.
ওখান থেকে ক্লিক করা যায়, চাপ দাও। ওখানে চাপ দিতে হবে।
But I would like to say,
উপরে অপশন দেখো।
আচ্ছা ঠিক আছে এদিকে আমরা করে যাচ্ছি।
No, just একটা ভিউ। আর তুমি এমনিতে ইয়াতে রাখো। কোনো ফোল্ডার সিলেক্ট করা লাগবে না, ওকে করে দাও।
এখানে নাম লেখেন।
IMM এ সেভ করেন, IMM সিলেক্ট করেন, বাস।
Okay.
sounds like a woodpecker. Okay, so we've gone through a lot this week. Not only in theory, but we've done it in practical. It's a lot to take in. I do understand you've had to listen to a strange Australian accent. I would like to say I think you've all done extremely well. I'm very proud of the effort you put in this week and that you've actually taken all this information in.
Yeah.
I'm hearing from you today that you are remembering most of this, which is great. I guess it's up to you now to continue on. You've learnt enough that you can go down there and do some test work, change some parameters, do the analysis. From that, you go away and make some other changes. And I hope that in 5 or 6 months' time I get an email from you saying, Nick, we've created this amazing flow sheet and I'm sure you'll be able to do it. That's a world-class facility down there. It's a great plant. Your dry laboratory here is great. I would suggest that you set up a compressor, air compressor down there in the where the magnets and the electrostatics are, because you need to clean the machine.
Yes.
With fine mineral, a brush is not good enough because it sticks.
Yeah.
You need to blow it off. Okay.
Just blow.
Blow on.
So blower already they have.
We
And
have blower.
obviously if they have, then
So we.
You've also learnt a little trick about making up some sugar solution
Yeah.
and making a nice slide. Remember to roll it on the paper.
Yeah.
Make a nice slide.
Yes.
Now, with those slides, because the material will not come off, if you're working for different clients, you can actually store those slides under their project name,
yeah.
and you can keep them for years.
So I think
So one more little thing we could talk about. So the recleaner tail is currently going into a bucket.
Yes.
In fact, all your products are going into buckets.
Recleaner trail.
yeah.
Tail.
So
When
recleaner tail, I think you should do a trial.
Yes.
I think you should take the recleaner tail and put it back into the feed to the cleaner.
To the cleaner or
Feed to the cleaner spiral.
to the cleaner.
Feeding to the
So I'm not going to tell you where that is, but you're going to look at your flow sheet, you're going to follow your pipes, and where your rougher and scavcon come down into a pump, that feeds the cleaner.
That is pump sum 2.
Okay. So that we could trial, bringing the recleaner tail back into there, run the plant, see how it performs. The purpose in the current design, because it's a batch fed, this plant is a batch fed plant. The current design was to take that recleaner tail and make a stockpile. From that stockpile, we feed the shaking table by hand. There is too much volume in that pipe to run directly to the shaking table. Now, in the future, if you want to run continuously, you can purchase a bigger table. Okay? Because I know at the moment you're only doing test work to design your flow sheet, but I can see down the road that you might start wanting to run some tons per day. So at that point, you might want to suggest you buy a shaking table, a half size or a full size. These gentlemen can help you with that, and you can set up a full size table which could handle that full flow. So now it will be continuous operation.
Yeah. Right.
We need to consider the UCC in this plant because you have fine silica. Okay, it's going to become part of your plant. The other thing I want to talk about is the buckets that you're using. The buckets, it's a great idea, so don't take any insults from this, but they're only good for an hour or two. Once the buckets are overflowing, because your mineral is fine,
Yes.
the mineral will overflow because the bucket is boiling
Boil.
from the volume from the pipe. It's boiling, so it's all going to overflow down the floor, down the drain, and we've just lost all that effort.
Lost some minerals.
So a lot of people use, in a plant, a lot of people use a thing called a kibble. So a kibble is like a big wheelbarrow on wheels. And these kibbles can be so big, a cubic metre, with big pneumatic wheels, rubber wheels. And when it's almost full, you have two of them. When it's almost full, you pull one away, you push the other one in, and they can take that one away, shovel out, and bring it back ready again. That way there's nothing going on the floor.
Yes.
On the outside of your building, where your tailings are currently going into those big containers, I would suggest you remove the containers and put some bund walls about so high, and that sand can pile up on the concrete slab.
Yes.
The water will run back into your drain, and then it's easy for the people to access and shovel. Just things to make life easier.
Apart from this, do
so-
you have any question?
Rana, I'll go back. If you can, if somebody can supply me some A3 or A3 paper, is that possible?
Yeah, of course.
Maybe 2 sheets,
A3 size.
Or
that's it.
even A4. I'll just draw it small. So if you can give me 2 or 3 sheets of
স্যারের রুমে
A4,
থাকতে পারে প্রিন্টারে রেখে নেয়
I will hand draw a picture, a diagram of a hopper for your UCC.
কি যে 3 আছে?
A3 না A4.
স্যারের রুমে কি A4 সাইজের পেপার আছে কিনা
আছে।
নিয়ে আসেন
So I couldn't remember anything. what I have remembered, I have already put down on the blackboard.
Oh, look, I think you've done well. You've had to take in a lot of information this week.
Yeah.
So if you have any questions, you have these two gentlemen here that can always assist. I'm a retired person, so I don't want to be working every day. But if you have some questions, forward them to me and I'll see where I can help you.
Yeah.
Okay?
Okay. Shalom bhai, Shola bhai.
Okay, everything is good. I learned many things from you people.
Vote of thanks devo naki?
Look, I will tell you this now. You'll be learning for the rest of your life.
Yeah.
Always.
Okay? And that is a good thing. If you're not learning, that means you've made no mistakes. If you don't make mistakes, you don't learn.
Yeah.
So don't be afraid. Don't be afraid to change your parameter.
Yeah.
If the pump bogs, don't argue with each other. Just say, whoa, we learned that that was not the right thing to do.
Yes. From there only you can
Okay.
learn. And what mistakes you did and what correction need to be done.
So if you want to talk to your management team about your dry limbs, about the UC upcurrent classifier, you talk to them, you get their approval, and then you have this wonderful gentleman here that can help you.
Yes, let them use the existing Paris cross flow, and if it is giving good results and they are happy with that, then
We will
definitely, yes.
take a steps. Okay, gentlemen. As the evening prayer is coming very soon, so I
Sure.
would like to finish and at last we'd like to give a vote of thanks.
Thank you.
Vote of thanks. First of all, I would like to express my gratitude to our staff. Without them, it was impossible for us to conduct the whole
Exactly.
training session.
Definitely.
Secondly, I'd like to thank the authority for arranging such a wonderful training session from which we learned a lot. And then I'd like to express my gratitude to Regia, Shiv Shankar Dada, and as well as
It's our
Shudha Dada
pleasure.
for the wonderful training. The whole training session was really practical way of teaching. They gave us a lot of instructive as well as informative lesson, and we hope that all the scientists, all the technicians who are available here will implement this knowledge in the later stages, and hopefully we are optimistic that we will get better result that we got before.
You will.
And lastly, I'd like to express my gratitude to my colleagues for their support throughout the work, and I also apologize to my colleagues and staff. Sometimes I might behave very rude with them, so please apologize me. So
No
that's
problem.
all. Thank you.
Thank you. Well done. Eamon.
Thanks.